lost our minds in the darkness of night. We live to die. We lose our souls every day. We lost our minds. We don't remember what's wrong and what's right. What's right. The world is dead but we stay. 'Cause we are born as living fights. We live to die. We live to die. And we surrounded by the night. We live to die. We are shadows in the neon light. We are shadows in the neon light. We are just shadows. It's supposed to be that we die. It doesn't matter if there is no light anymore, no light anymore. 'Cause we are born as living fights. We live to die. We live to die. And we surrounded by the night. We live to die. We are shadows in the neon light. We are shadows in the neon light.
Some form of control still, making our constant binary choices and voicing our equally shallow opinions more loudly or quietly. Most people can't even decide what color to wear or which burger to eat. What does it matter, man? Autonomy is an illusion. Autonomy is an illusion.
Okay, we are live streaming the 5th chapter of the ARRL Technician License Course. Tonight's plan is divided up into 3 different sections. The first section is modulation and bandwidth. The second session with Doug, KC9VFI, will be doing is all about transceivers, receivers, and transmitters. And then the third section will be back to me, and that'll be on power supplies. So we'll have a little bit of a break in between each of those two so you can get stretch your legs, whatever. Anyway, getting started with tonight, modulation and bandwidth. Modulation is when we mess with the carrier, so we send it out over into the air, so some guy on the other side of the world or the county or somewhere picks up that signal, brings the signal down into his radio, and then he demodulates it. He takes that, whatever information we got, and he, with his radio, will send it to the speaker or maybe to a computer monitor, whatever we've sent him. Every radio has got a modulator and every radio's got a demodulator. They can do without some other circuits, but they have to have those two. Also going to be talking about bandwidth. Bandwidth is how much of the radio spectrum you take up. You want to take up as little spectrum as you can, so there's more room for other guys to have fun. The basic radio system is, of course, you got a transmitter and a separate receiver. Back in the old days, there were literally separate transmitter, big boxes, and big boxes for receivers. Then they had power supply in them. And this power supply, of course, fed both the transmitter and the receiver. And then, of course, in between, we had the TR switch where you could switch the receiver to go up to the antenna or switch the transmitter to go up to the antenna. That's a basic radio station, and that's what we're going to be talking about tonight. Basically what happens, it's kind of common sense stuff here. We transform voice, we use a microphone, send that voice electronically into the radio. It takes that electronics variation, puts it on the carrier. It is the all electronic and it's added to the radio wave, so that's modulation. This way we vary this radio wave, like I said, it could be TV, it could be voice, it could be Morse code, data stuff. Receiving is just the opposite happens. The radio wave hits somebody's antenna somewhere. It goes down to the radio, and then the radio extracts that information off of it. And like I said, it can be any kind of information, whatever you want. Adding or extracting the information, adding is modulation, extracting is demodulation, can be very simple or it can be very complex. If it's a simple Morse code, it's very simple. You only need a couple circuits. If you're talking about an FM signal, then we're talking some complex circuits. But they say that's what makes it fun, learning about how all the different radios work and how to do it. So, we don't want you to be intimidated tonight when we're talking about modulation. It's just the very basics of modulation, the introduction to it. So, here we go. First, we have to add some information to the radio wave, the carrier. We modulate the wave. In Morse code, you just literally turn it off and on. That is one way of doing it. You just turn off and on the carrier. But when we put speech or music on it, that's when we have to change that wave somehow. If we have to put voice data on it, we all have to change that. And the way we do it is we change the different properties of that wave. We change either the amplitude, the frequency, or the phase. If you're talking voice using sideband with amplitude modulated, you know, the signal will go up and down like this. If we're on FM, like a 2-meter repeater here in town or walkie-talkie, the frequency goes like this. A lot of people remember it. AM is like this, FM is like this. FM takes up a lot of space, radio space. Phase is almost like frequency. You really won't get into that too much, although in some areas of amateur radio, they do use phase modulation for digital communications. Along with the frequency period is the in or out of phase. You can sort of see 2 sine waves here. If you go after the extra class, which I hope you all do, you'll be learning about Eli the Iceman. It is a way to know if the current is leading or lagging the voltage in your signal. And that lag between the two is how you can actually modulate. But like I say, you guys probably won't even run into that, but it is one way of doing it. Morse code is simply on and off. There is another type of Morse code called modulated Morse code, is where this dash here, this long signal, would actually have an audio tone superimposed on it. But basically CW is just strictly on and off. Back in the old days when you had to do Morse code tests, the entry level, you had to do Morse code at 5 words a minute, which basically was 1 letter every 2 seconds they would send at you. A lot of people would complain they wouldn't get their ham license because they were tone deaf. Has nothing to do with tone. It's the length of the tone. It's either a short dit or a longer dash. Amplitude modulation. And that is when we vary the amplitude. This is a voice. This might be our voice saying 7. What it might look like on an oscilloscope if you said the word 7. You put that on top of a carrier, it looks like this. So when it gets to the receiver, what the receiver does, they take all this RF and they dump it to ground, leaving just the audio on top of it. And that is amplitude modulated. It's going up and down. Composite signals are basically a bunch called sidebands. We learned that a mixer, we could take 2 frequencies into it and you put a mixer and you get 1 frequency out. Sideband is a lot like that. With a sideband, we take the voice frequencies, which is really low, combine that with the RF frequency, which is really high, maybe 28.4 megahertz if you're operating on the 10 meter band. And when it gets out into the air, you're going to have 1 frequency going out there really strong on 28.4 megahertz. Then you're also going to have another one called the upper sideband and another one called the lower sideband. And this one is the subtraction or the addition of your voice frequency to it. 28.4 plus whatever your voice frequency is. Those are the sidebands. And it's called a composite signal when it's like that. The bandwidth is how much different frequencies occupy different ranges of the spectrum. The occupied range of a composite signal's bandwidth is fairly large. And there's a lot of differences. CW is very small. Sideband is the next smallest, and then you go to FM. The characteristics of voice AM. AM signals, just like the one when you tune in WCRA out here on the radio station. It's got the main carrier frequency where your dial is on, and then it's got these 2 sidebands, which is this sideband, which is the carrier plus the voice frequency, is this right here. The carrier plus the minus side is the lower sideband. The neat part about it is, of course, is these things have all the same frequency or all the same information on it. Give you an idea right here. This information right here is identical to this information right here, and you've got this big wide bandwidth area that this is occupying. So when we go into sideband, we could just eliminate one of the sidebands. Since they both have the same information, we can just eliminate it and just use this side. That leaves these frequencies open for someone else to use. That's why you go to sideband. So you don't use this entire area, you just use this very smaller area to do it. The sideband is only 3,000 hertz wide for a voice, 3,000 cycles wide. You can hear that, 3,000 cycles. CW is only 150 cycles. So you can see 150 cycles is a lot narrower than the 3,000 cycles for voice. The frequency takes up the most room. And with the frequency when you're talking, the frequency varies in conjunction with your voice amplitude, right? So the louder you talk, the wider the signal goes out. This is one of the big problems you guys got to watch out when you're using walkie-talkies. Never shout into the walkie-talkie. It's just going to mess things up, make your signal worse. You'll see it on movies all the time, and you'll cringe since you'll know this now. You know, they didn't hear you, so he starts yelling into it. Totally the wrong thing to do. It's designed for a certain level of voice to work right, and that's what you got to deal with. You never want to yell into the mic. The FM bandwidth, between 5 to 15. They usually say about 10 kc wide. So now we've got CW at 150 wide, 150 cycles. We've got sideband at 3,000 cycles. And now we've got FM at 15,000 cycles. So it gets really wide and takes up more and more space. Okay. This you'll kind of have to know. I'll get into that in a little bit later on about the typical bandwidths. You'll need to know that CW is the narrowest. You'll need to know that sideband is the next narrowest, and then FM is the widest. So, in fact, here comes the questions now. Why should you not set your transmit frequency on the exact edge of an amateur band or subband? And what they're talking about here is, let's say that you guys, with your technician class license, will be able to operate from 28.3 to 28.5 on the 10-meter band. Now, this is going to get exciting in a couple of years, 10-meter band, but right now it's kind of dead. But you get to operate from 28.3, so you don't want to turn your radio to 28.3. You want to go up just a little bit above 28.3 because you know your side bands and everything else might drift down below 28.3. And that's what you got to stay in. Especially on contests, you'll hear guys almost arguing during contests, which is a big no-no to argue. But they'll go right down on the edge of the band, and he'll be talking, and someone will say, you know, you ought to move up about 3 kc. You're right on the edge of the band. And he says, oh, I'm operating upper side band, so none of my signal is going below. Well, he was dead wrong. There is always some lower sideband in on the thing. But the reason you should not set your transmit is simply because it's, and I think this is one of the all of the above questions where all of the above are correct. You got to allow for calibration error on the transmitter frequency display. Not so much anymore with the new digital displays. But back in the old days when you had the vernier dial, you know, it wasn't always totally accurate. So you want to stay away from the edge because you might think you're not on the edge when you are. Modulation sidebands do not extend below the band edge. If you're up on the top part of the band, you got to be very careful using upper sideband because your signal might go up and over and out of the side. And then allow just for transmitter drift. We don't have much transmitter drift anymore. If you got an old tube type radio, you will have transmitter drift. But the new solid state stuff is really stable. Read this one very carefully. There might be a problem if a repeater says your transmissions are breaking up on voice peaks. And what they're talking about is you're talking too loudly. You're yelling again. So you want to make sure that if this would ever come up later on in life, that if someone tells you you're talking too loud, you're talking too loudly. You don't want to talk loud. What types of tones are used to control repeaters linked by the IRLP protocol? DTFM, dual tone, multiple frequency. The same tones you hear that if you pick up a phone and do your phone, you're like, doot, 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 doot. That's a DTMF. What is the following form of amplitude modulation? We already know this, right? It's single sideband. And amplitude modulation, you can transmit both sidebands, an AM carrier, if you want to. I mean, you're allowed to. This is just gentleman agreement type stuff. But you can transmit AM, but why transmit AM? You're taking up twice the space as if you go sideband. So that's why you want to use sideband. It is a form of amplitude modulation. Type of modulation used for VHF packet radio transmissions. The packet radio transmission is basically you're sending a message from your computer to another computer somewhere. It's FM. You use FM for that. Okay. This, and there's another question very similar to this. Make sure you know these two coming up here. This one is what a type of voice modulation is most often used for UHF and VHF. It is single sideband. When you're just using a repeater or talking handheld to handheld, it'll be an FM signal. But if you get out on your base and you want to do some contesting or something on 2 meters or on UHF, VHF, you'll be using single sideband. And the type of modulation for the VHF, UHF repeaters is FM. Here we go. Make sure you know this one. Which sideband is normally used for 10 meters, HF, VHF, and UHF single sideband communications? It's upper sideband. You'll use. So if the question comes up, the answer is always, it's either you use sideband or it might include 10 meters here where you use the upper sideband. If you go below the 30-meter band, you start like down in 7 point something, you start using lower sideband. And then above about 10 megahertz, yeah, above 10 megahertz and below 10, that's the cutoff between you using upper sideband and lower sideband. I was told that the reason that they use lower sideband was back after World War II, a lot of the equipment was being on the market, you know, and amateurs was buying it up, and the military did use lower sideband a lot. And so that's, and then they just come up with this gentleman's agreement. There's no really rhyme or reason why above 10 megs you use upper sideband, below you use lower sideband. It's just the way things turned out. But you do have to know that on the 10-meter band, on all the HF bands, VHF and UHF, you use upper sideband. And like I said, it's just a gentleman's agreement. You can use lower sideband if you want to, but it just messes up the band. It's too much noise on it. The primary advantage of sideband over FM for voice transmissions is sideband has that narrower bandwidth, so more people can get on the air. The signal is going to go just as far, whether it's a sideband signal or an FM signal. But sideband is narrower, so you use it. The approximate bandwidth of a VHF with FM phone is between 20 and 15 kilohertz. 20 and 15 kilohertz. 20 or 10? 10, I'm sorry. Getting the glare off the light. Typical bandwidth of the typical bandwidth of analog fast scan TV transmissions. That is television. Actual live television. You guys can have your own television stations if you want to. You do it on the 70-meter band, which is the 440 band. From 420 to 450 you're going to use. But those suckers take up 6 megahertz of space. So we went from CW at 150 cycles, now we're all the way up to television to 6 megacycles wide. So it's the big difference in the width of all these different signals. That's the bandwidth is all about. The television system, by the way, most of it, about 4.5 megs of it, is the actual picture information. It's AM, and then they got an FM signal on the tail end of it that comes to voiceover. The voice comes over. The approximate bandwidth required to transmit a CW signal is 150. So make sure 5 weeks from now you know CW is 150, sideband's about 3. You need to know which is the narrowest and which is the widest. Oh, I'm done. That was a quick one.
Anyway, there's 4 manufacturers of HF radio. There's a Linco, ICOM, Kenwood, and Yaesu. There's some differences between them. Most of the receiver you'll cover 10 meters through 160. Some of the other models will have the 6 meter band on them. There's various differences between them. HF radios, brand new, can cost you anywhere from $700 all the way up to $16,000. You're better off if you want just casual communications. You can use your entry model radios. I've compared some of the top line with the entry level. I see no advantage in them. And if you want all the whistles and bells and spend all your, with a volume that thick, it's fine. But there's no advantage in them. And most of your ham radios that you buy use 13.8 volts. Most of your radios on the market are 100 watts. You can go up to 200 watts, but they have a built-in power supply. Most of your HF radios, I would recommend a 25 to 30 watt power supply. Because when you modulate on sideband, you watch that ammeter on your peaks. It swings back and forth. But you want a steady 13.8 volts. Because if you turn that voltage down too far, it's going to shut your radio off. I did that accidentally one time. I was adjusting the voltage. I got down to 11 volts, and guess what? The radio turned off to protect it. So you got to watch that. And you want a good, stable power supply that's regulated. Don't buy those cheap things, because if you draw too much current, your voltage is going to drop down. You don't want that to happen. Okay, why isn't this thing moving up here? Let's see, that it's not moving up on me here. Oh. Okay. There we go. Transmitters, receivers, and transceivers. Generalized transceiver categories. Mobile, VHF, UHF-M. You can get a 2 meter mobile, a 2 meter 440 band mobile, and some of them now have got that new 220. You can get all 3 of them. Some of them have 6 meters and 10 meters. Single sideband, VHF, UHF-M. Dual band, VHF, UHF-FM. And there's a lot of companies that make mobile radios. Like I say, Yaesu, ICOM, Kenwood, and some Linco. All band, HF, UVHF, UHF. That's like your regular HF, your general transmitter. Multi-mode, VHF, UHF, CW, sideband, and FM. There's not many out there that cover all those modes. Handhelds. There's many, many manufacturers of handhelds. You can get a handheld for as cheap as $30. You can get it spent up to $500 or $600 from, depending on what you want on them. Single band mobile. Single band 2 meters sideband is a good starter radio. They don't have to be expensive. There's plenty of good ones on the market, but if you ever buy one, don't buy it on eBay. Buy it from an amateur, because we got a rule: we don't sell what we don't buy. Single band 2 meters, a good starter. Operates from 13.0 volts DC. Requires an external power supply or a car battery. Requires an external antenna. You can put one up on your roof or back in your trunk. Can be operated mobile or as a base station. So you can take one and put it in your house with a good external 2 meter antenna or a 440, use it in your house on a good power supply like I explained before. Limited to frequency modulation FM, usually either on 2 meters or 70 centimeters is the 440. up to approximately 50 watts output. Now some of those have an 80 watt. My Yaesu 2 meters, 80 watts output. Dual band mobile. Same as single sideband transceiver, two additional bands. You got your 2 meter band and your 440. Most common are 2 meter and 70 centimeter bands. Could add 6 meters, 220 or 1 gigahertz. That 220 is not very commonly used. 6 meters is the magic band. I wouldn't bother with it. That's very, very iffy band. That's your 50 to 50 more megahertz band. I wouldn't even bother with that. Might have separate antenna connectors for each band or signal connection for a dual band antenna. Multi-mode transceiver. Nearly all HF rigs are multi-mode. Upper sideband, lower sideband, FM or AM. VHF multi operates on FM plus AM single sideband CW modes. My one radio I've got at home, my ICOM 746 Pro, one advantage is I can work single sideband on 2 meters. There's not many radios that have sideband 2 meters on them. More features add more complexity and cost, which is right. More flexibility will allow you to explore numerous models you gain experience. Like I say, get yourself a radio. You don't have to put a lot of money into it. Get used to the feel of it. A lot of people say, is one radio any better than the other? It isn't. It's what fits your budget and what you want to use it for. You don't have to buy the top of the line stuff to have a good radio. Explore them. We have these field days. You guys come to the field days, get used to the radio, see how they work, see how we operate them. Like I said, there's 4 different manufacturers. There are differences between them. It's just what you want out of the radio. Multi-band transceiver covers many bands, usually refers to coverage of HF, VHF, UHF. Also covers all modes. Frequently 100 watts on some HF, some power limitations in the high bands. Usually up in your UHF and you're way up in your spectrum, you got a power limitation because of the penetration of the signals. The health hazards, safety hazards. Larger units have internal power supplies, smaller units need, like the smaller units like I was talking about, your base radios, your 100 watt radios. You get up to 200 watts, and if you get ever lucky to get that big Yaesu 9000 series, that's 400 watts. You're talking 70 pounds of radio. There are not too many of them sold. HT transceivers, small helmet like we had last week, just your small ones. They got many variations of those, many different manufacturers, many different price ranges. It's just what you want out of it. Single sideband or dual band. Select. Now they've got new digital handheld radios out. Digital takes a lot more battery. There's not too much digital activity around here. So it's limited power supply, usually 5 watts or less. ICOM has come out with a new radio. V86 has got 8 watts output on it. You got 4 selectable outputs on them. So you can vary that. My old ICOM at home, that's got 7 watts output. It's got 4 watts and a half. I can take the 4 watts into an external power supply or amplifier and get 40 watts out of it. So if I want to take my base unit out, I can put that in my truck or my car, put it in that little power amplifier, key it up, get 40 watts output out of it. Includes power, battery, and antenna all in one package. So everything you need to operate when you buy an HT, everything's all included in the box. You can buy extra microphones, extra batteries, carry cases, longer antennas. Often purchased as a starter rig, but has power limits range. Single, dual, and multi-band systems with increasing cost and complexity. Some can receive outside the ham band, such as an aircraft, commercial, FM broadcast. Some of your Bofang's are like that. And those HTs I got, They will not operate outside the amateur band, but you can listen to your police departments, your fire departments, and all the utilities and stuff. They will not transmit on those bands because they're not type accepted. Very portable and very self-contained. They are very small. They're lightweight. Internal microphone and speaker. It's all compact. Like I'm talking right now. It's a speaker microphone combination. Rubber duck antenna. That's the little short ones we showed you a couple weeks ago. There are external antennas about this long. Get you better range for them. I got one home that telescopes out to a 5/8 wave. I can sit there in my kitchen and talk to Effingham with it. It's a dual bander. Battery powered. Most of those batteries, internal batteries, are anywhere from 7.2 to 8.4 volts. You can buy the battery that comes with it. You can buy one that's got extra capacity to talk longer with it. Extra battery packs, that's an option. When you go in places like ham radio outlet or universal radio, they'll show you the options that come with a radio. It's all different. You can buy extra battery packs. You can do different power, different charging. It just depends on what you want. You can buy it like an external microphone, so you don't have to. It just plugs in the side already. You can talk like I'm talking right now to it. Extra battery packs, AA batteries. I got one at home for my Yaesu. I can put 6 AA batteries into it, but that's not recommended because that's only for emergency communications if your battery pack fails, because it doesn't have the capacity to keep that radio on very long. But that's something to think about. AA's, AAA, drop-in fast chargers. A lot of chargers have different charge rates to them. My old ICOM I've got 4 batteries for it, but the charge rate is what makes the difference. They'll charge you faster, but you don't want to overcharge them. Mine, they all shut off automatically, so you don't have to worry about that. Drop-in fast charger. What that does is charge it up. It's got a little bit more ampere outage capacity to it, so we're going to charge it up a little bit faster. An extended antenna pulls out like this, like the old car radios from years ago. You pull up the antennas and extend them. But now you can buy it looks like a dual band. It's only about 19 inches long. That works fine. Those little rubber duckies, if you're sitting in here and want to work our repeater, that's fine. But don't sit out 20 miles away and try to make a contact. You're not going to do it. External microphone and speaker. Mine have got a little bitty microphone about the size of this unit right here. It's got a speaker in it. You push that, it's like push to talk, like a regular microphone. That's an option with it. Nice thing about that, you can clip your microphone down here, your radio down here, have your microphone up here. You're keeping away from the antenna. Remember what they said, you don't want that antenna right in your eyes. Headset. Some of those, you can work Vox operation. Have your headset up like I got here, you can talk into it. Side by side. Single band, let's see. Limited. Functionality limited. You got all these different modes. What's your function? What you want to use a radio for? We will now go through some jargon and vocabulary specific to receive and transmit functions controls of a transceiver. Band and frequency selection. Fundamental to all amateur transceivers. Can set by VFO, continuously variable, or by direct keypad. Direct keypad I've got on mine, on my radios. I can just push a certain button. I don't have to turn that VFO. I can just punch in the exact frequency I want. Memories can be generally stored, like certain nets I like to work. You can program those in your radio. On those HTs that you buy, you can buy programming software from RT Engineering. You can program all those different frequencies that you want to use on an HT. And the advantage of that is you can program that into there. You print it out. You can print that out, and you know exactly what you've got in there. So if you make a mistake and push the wrong button, you can go back and reload that into it. It's much easier to use that programming than it is to try and manually put all that stuff in there. Store more frequency, more modes, filter in similar settings, alphanumeric labels. There's all kinds of things you can put on those HTs, depending what you want to use them for. If you want to use it for regular, like we do around the talk, to the repeater, program your frequency and your tone into it. Transmitter controls and functions. Main tuning display using both TX. TX is transmit, RX is receive. Remember, T is transmit, R is receive. Controls are frequency selection by the variable frequency oscillator. Frequency being set with a knob or a key batter program channels. That's the nice thing about them. When they're programmed in, all you do is turn that dial, it brings up that station automatically for you. Now some of those, you could even put the call letters into it, or the location. That's what I got in my little handheld at home. So I don't have to look at the frequency, all right? I've got Effingham in there. I got Mattoon, Springfield, whatever I want. Turn the dial, you don't have to worry about frequency. That could all be added to it with the RT systems. It just depends on how you want to put it in there. Variable frequency step size, tuning rate, and resolution. You don't have to worry about resolution or tuning rates too much. Rates can usually store more information than two operating frequencies, VFO and VFOB. Like in my dual band at home. VFOA is 2 meters, the other side is 440. Mode selection, TX and Rs are multiple mode rigs. AM, FM sideband, lower or upper sideband. CW. That's on your HF rigs. Your handsets don't have they don't have CW capability to it. Data, radio or PSK, could be automatic based on recognized band plans. Transmitter controls, you got microphone controls, gain, your microphone gain, controls transmitter and sensitivity to your voice. That's when you're talking to a microphone, you don't want to overmodulate. Just like you're talking on a handset, on HF, you don't want to overdrive it because you're splattered and you're going to go off frequency. I've heard people that shout in those radios, you can't understand what they're saying. It gets garbled because they're going off frequency and they're splattering. Speech compressor, speech processor, that shapes the tone of your voice, adds a little bit more power to your sideband. Increases microphone gain for lower sound levels to increase an overall signal strength or punch. You can adjust your microphone gain, but most radios have what they call an ALC function on automatic level control. You don't want to go over that because you'll splatter. Too much gain and compression can cause problems. Splatter, over deviation, over modulation. That you want to be careful of. Because when somebody's trying to, like, work Europe, and you get on here and you talk too loud, you're going to cause problems with those guys. Automatic level control, I see it. Automatically limits speech modulation, reducing transmitter overdrive. That you got to be careful of, no matter what you get. Some cause speech distortion. If you scream like what Russ was talking about, a HT, you don't want to yell into it. You're just going to have all kinds of problems with it. Do not use for data modes like PSK. Also, previous overdrive to extend power amplifier. That you don't want to do either because most of those power amplifiers, they've got what they call a peak limit on it. What I've got home is 40 amps, 45 peak. Now, if I was to try to put up a 200-watt radio to that, it wouldn't work. The minute you key up, it's going to go over the power range. It's going to shut it off. Microphones, mic, like I'm talking, like this here. Hand mics, you got little hand mics that you can buy. Most of your HF rigs have a hand mic with them. Some have an up and down feature. Some you control other different things depending on what you want for your radio. desk microphones. That sits on your desk. They got various forms of those, various expenses. Preamplified desk mics. That's if you want them. I don't see any advantage. I like the regular hand mic. It works fine. Most of your hand mics and your HF radios are 600 ohms. Speaker mics, like a speaking, talk and receive to it at the same time. In fact, you can take an old radio loudspeaker and make it into a microphone, but it's not the same impedance. I've done that before, years ago, played around. Took an old speaker microphone and talked into it and made a microphone out of it. It's just headsets are boom sets. It's like I've got here. A lot of people don't use them. A lot of people in their contests, like on field days, they'll put a headset on and a microphone and a foot control to talk, and the foot control. That way you got your hands free when you want to log contesting or log stations. Internal microphones. All your HDs have internal microphones. Your little handsets all have internal microphones on them. You don't have to worry about it. You can buy an external microphone if you want. Speak across the mic, not into the mic, like this. Because you get too much in there. Transmitter off and on or keying. Push to talk, like this. On a regular push to talk microphone. You push in the transmit, let go to receive. It switches it automatically inside your radio. Voice operator transmission, Vox. I can use Vox. I don't have to push the button. When you talk into your microphone, it changes the internal parts of the radio. It's called Vox operation. But you have to be careful of the delay on that, because once you stop talking, it might be 3 or 4 seconds before you can receive. But that's adjustable inside your radio. Vox operation, you can, like in a desk microphone, you can set your Vox operation on a desk microphone. So you don't have to sit there and hold their key all the time. That's one advantage into it. Vox gain, that you got to be careful. Your Vox is voice operator control. You got to be careful your gain factor on that also. Vox delay, you can set your Vox delay on that. But you want to be careful of that, because once you stop talking, if you don't set that right, before you hear the other station coming in, you're going to have a delay in that. And if you're trying to make some good DX contesting, and you lose that, you won't be very happy. Anti-Vox. Key jack, that's for your microphone. CW keys or paddles. Manually operated transmission, Mach or SEN, varies with manufacturer. Morse code. Most of your HF radios are capable of the Morse code, but you need an external key for it. You'll telegraph key, or if you want the paddle. Straight key, which is like this. Electronic key or paddle, you can do back and forth like this with it. Semi-automatic bug, that's for people that are very good at CW. Receiver controls and functions. AF gain. Controls the audio level of the speaker or the headphones. To the speaker or the headphones. That you want to be very careful of. RF gain. Controls the gain of the receiver's input amplifiers. So if you get a very strong signal, which you will get sometimes, you can back that gain down so you don't overload what they call the front end of the radio. It doesn't overload it. Attenuator. Reduces the signal at the receiver input. If you get a very, very strong signal, you can put what they call a decibel attenuation into it. That cuts down that overload of the front end. Receive incremental tuning, RIT. That's for fine tuning. Let's say I'm working somebody in 14300. They might be just off a little bit below or a little bit above that. They might sound a little garbled. You can adjust that knob to vary that. And you see it on your display. They might be 150 hertz below that or 150 hertz above it. Because that's, some people are not, like on 14300, they might not be right on 14300. They might be on 14310, 14305, somewhere in there. So when you try to tune these guys in, You turn your dial very slowly so you can pick them up. And that's what that RIT is for. Adjust the receive frequency independent of the main VFO. So I set that on 14,300. That RIT is going to adjust that receive level above or below what they're talking on. And that's a lot of times when you want to pick up a good signal, that's what happens with it. Doesn't vary the transmit frequency. You don't have to worry about that. Transmitters have a similar function, automatic gain control. Automatically limits the incoming signals during signal voice peaks to maintain an even volume. Because some guys can get really loud into a radio, talk too loud, that overloads what they call the front end of the radio and makes it distorted, makes it hard to understand them. Keep strong signals from blasting the listener, especially if you got earphones on. Define different time response settings, fast settings for CW. When you work in CW, you want that AGC very fast. So you work sideband, I normally put it on slow. Slow settings for single sideband and AM. Not using FM because an amplitude is constant. You don't have any variations in the amplitude. Receiver controls and functions. Got your squelch control. Mutes the audio to speaker when signal is not present. So let's say I'm on HF for instance. I can mute that down when there's no signal. You don't get that background noise in it. Used in FM primarily. Open allows weak signals to pass through along with noise. Tight allows only the strongest signals to pass. So if you got a real strong signal, you want that to pass. You don't want the weak ones, you don't want the noise coming in, so you can adjust that for that. Receiver controls it. Advance the squelch control to the noise just disappears. Normally, if you turn it clockwise, the noise will disappear. You turn it counterclockwise, your noise, that's all that background noise that you're going to get when somebody's not on the particular frequency. Also operate by monitor function control on handhelds. Filters can be electronic modular digital signal processors. IF filter, IF is intermediate frequency, can be used to narrow the width of a signal that is passed. Can attenuate adjacent signals, like some of these guys in contesting, 14,300, 14,302, they're going to try and cram each other. That spacing eliminates that. Notch filter. Very narrow filter can be used to move over interfering signals to attenuate. Like I was talking before, you can notch these guys out. Let's say I'm on 14,225, there's people close to it, they're too close, I can notch that out and pick up only the desired signal that you want. Noise blanker. Like your automobiles going by. Spark plugs years ago used to create noise in them. You don't need that too much anymore. But most of your radios have that feature in them. Can cause problems if strong signals are present. Mostly automobile noise. Some of your electronic equipment inside, you give it that clicking and noise. You can notch. That's what that signal, that noise blanker is for. Noise reduction. Digital signal processor to remove noise from the signal. My one radio I got almost got that in there. So if somebody's working digital on the HF bands, it'll attenuate that. Makes it a little better, it makes it easier for you to understand. Noise limiter. Simply limits the maximum viable noise pulse. Preamplifier. Increases sensitivity but can cause overload. You want to be careful that you never overload the front, what they call the front end of your radio. Never overload it. It causes distortion, makes the signal hard to understand. Reception and transmission meter. And transmit it indicates the output power or ALC or other functions selected by the switch setting. And receive it, and we call it an S meter. S meters are from 0 all the way up to 10 to 20 dBs. When you receive a signal, you watch this S meter bounce like this. Like the guys in New Orleans I talked to, what am I reading? Well, you're a S9 or 55, or sometimes, well, you're 10 over. Some of these guys will be 20 over, which is not very common, but it does. You're 20 over S9, then I say you got a very strong signal. When you transmit, there's a meter on that sways back and forth that shows you power limits. As you modulate, you see it go off anywhere from 0 to 100. An S unit, S1 through S9, S9 is the strongest. Above F9 meters is calibrated in decibels. Receivers can be limited to hand bands or cover other parts of the spectrum. General coverage receivers, like you could buy a shortwave radio that you can pick up the amateur bands, your broadcast bands, and some of your international bands like the 41 meter band and all the, but to receive sideband, you have to have a sideband control on the radio. They'll pick up AM, FM, sideband, or CW. Data modes, computer-to-computer communication. That's what these new digital modes are. That's something new in the market. I'm experimenting with it right now. Specialized modems. Terminal node controller. It's like a sound card. That's why I'm trying to get on this new FT8 mode. Has to hook up to my radio, go through your screen. It's a learning process. Multi-protocol MPC, that's not too, computer sound card software. That's what I'm using right now for the digital modes. Yes, WSJT, but that sound card is what I got when it's called, it's a little bit, no bigger than a pack of cigarettes. That plugs into the antenna and interfaces into my computer. But when you're working these new digital modes, there's a power limit. Most of your external tuners will not take over 30 to 40 watts of digital mode. So you got to be careful and use digital bands that you don't overdrive that transmitter or your amplifier or your tuner. Requires a radio interface that plugs in the back of your radio. My sound card plugs in the back of the radio, but each one is configured for a particular radio. You can't buy just any sound card and hook it up to any radio because the characteristics are different on them. My Kenwood is the one I got is specifically tuned to my Kenwood radio. If I want to use my ICOM or my Yaesu, I have to buy a separate sound card for them. Popular digital modes and systems. Radio teletype, that's ready. That's a very, very fast teletype. It's very, very fast. Beep, 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 all kinds of noise and stuff. Not too many radios will that's not a very commonly used mode anymore. PSK 31, Pascal 31, MSFK, packet radio impactor, CW, that's your international Morse code. That's off and on. It's either off or it's on. That's called automatic packet reporting systems. Some of your 220 bands use some of that. FT8 digital modes. FT8 is getting to be a very popular mode because you don't have to have a lot of power. You don't even have to pick up a microphone. When you get that process in there, you put your call sign in there and your frequency that you want, and you set up your controls, it'll transmit your signal out. My pastor friend and I have worked Australia on 30 watts using FT8 modes. Just using those digital modes, you can reduce your output power back. I've seen people that worked all continents, especially in Europe, worked all the United States stations, worked every country. It's hard to do that in single sideband because of the time variations through the world, the different FCC rules. They can do it with the FT. You don't even have to pick up a speaker. It's all done through your computer and your sound card. Winglet system, error detection. Yes, packet radio MFSK. That's an error detection in that. No RIDI or PSK31. Error correction. MSK, forward error correction, or FEC. Packet radio, checksums and call signs. Here's your station sub. You got your transceiver there. Here's that little, here's your transceiver, here's your computer, here's your sound card, your terminal node controller, there's all your interconnections here, and there's your computer. It all works, it's all interlinked together. And once you get it set up, it's not that hard to use it. There's different manufacturers of sound cards and different modems to use. Internet gateway. That's something new that's out. Now there's some programs now that you can buy. If, let's say I want to go to a motel somewhere, I can hook that up with a computer and use my base station at home. So I don't have to lug that stuff around. And some now that's my Kenwood in my vehicle, I can link that up through the repeater and operate my HF station at home. That's another advantage, but you got to be in a repeater range to do it. And they don't like you tying up repeaters that long. Automatic position reporting systems. That's like GPS. Some of your HTs have them. Some of your Yaesu HTs have that in there. So if you're lost somewhere or something you can't talk, it'll pick up like GPS exactly where you're at. That's a nice function to have in those HTs. If a station is not strong enough to keep a repeater squelch open, which of the following might you allow to receive the signal? TB, that's your question there. T3 or T2B03. Listen on the repeater input. If a station is not strong enough to keep a repeater squelch open, which of the following might allow you to receive? Listen on the input frequency. You got an input frequency and an output frequency. Which is considered determination of current capacity for power transceiver's power supply? Efficiency of transmit full output. So if you buy an HF rig, you want something with at least a 25 to 31 amplifier or power supply. That'll cover it. Because depending on the radio, your transmission modes, most will operate 100 watts, about 20 amps to 25, depending on the radio. But you want a little bit of deviation on it, what they call peaks. Mine's rated at 40 amps. I can get a 45 amp surge out of it, but it's just for a few seconds. How might a computer be used as an amateur radio station? For logging contacts and contact information, for sending and receiving CW, for generating and decoding digital signals. Which of the following connections might be used between a voice transceiver and a computer digital operation? Receive, audio, transmit, or push to talk. How is the computer sound card used when conducting digital communications? Question T4AO. You should remember that one. The sound card provides the audio to the radio's microphone input and converts it to digital form. So you're not talking at all. The computer does it all for you. A lot of people use it because it's the new band. They don't have to do anything. But to me, talking on the radio, that's the fun part of it. What may happen if a transmitter is operated within the microphone gain set too high? To get a lot of distortion. So if I start screaming at you, I'm going to sound distorted, right? Which of the following can be used to enter an operating frequency on a modern transceiver? The keypad or the VFO. That's the one you turn to see your frequency. Or a keypad. The digital readouts like you see now, like up here. The old ones you had to turn it like this, hope you're right on frequency. But now with the new digital, it's or you don't have to turn your dial. You can just enter on your keypad if you want it in there. What is the purpose of squelch control of the transceiver? Question T4B03. Remember to study that one. It might be on your test. To mute the receiver output when no signal is being heard. That's all that's for. You don't get all that hiss and modulation and all that noise and stuff in there. What is the quick way to enable quick access to a favorite frequency on your transceiver? Use a memory mode. Store the frequency in a memory mode. A lot of your HTs, you can do that. So all you have to do is turn that little dial on there. You got your next station. It's all set up. Your power limits, your offsets, and everything are all set up on there for you. Which of the following reducing ignition interference to receiver? That's the noise blanker. But the new cars that got on the new electronic ignition, you don't have to worry about that too much anymore. Years ago, it affected television. Which of the following controls could be used if the voice pitch of a single sideband signal seems too low? The return of the RIT or clarifier, they're both the same thing. Like I said, if I'm on 14.225 and somebody's slightly off frequency, I can tune them in so I can hear them. What does the RIT means? To receive increment turning. That's what RIT means. What is the advantage of having a multi-band receive radio and choice of a multi-mode transceiver? Permits noise or interference reduction by selecting a bandwidth matching the mode. Which of the following is an appropriate receive filter to select in order to minimize noise and interference for single sideband reception? 2400 hertz. Which of the following is an appropriate receive filter bandwidth to select for minimizing noise and interference for CW? 500 hertz. Those are all going to be in your test, so you got to memorize that. What is the following function of an automatic gain controller AGC? To keep received audio frequency constant, so you get those swings. What is meant by the term PTT? That's push to talk. The push-to-talk function switches between receive and transmit. That's done with a relay inside your radio. Some use solid state, some use a relay. You can hear click, click as it switches back and forth. The function of a single sideband FCW FM switch on a VHF power supply. Set the amplifier to proper operation on the selected mode. Yeah. Okay. T7809, T7 Alpha Oscar 9. Okay. Like I say, set the amplifier for proper operation in selected mode. You get these big power amplifiers, you got to be very careful of them. You could overdrive them, and if you don't have a good ground on them, you got your own 4th of July. Power amplifiers you got to be very careful of. Not all of antennas will take that power. So you just go out and randomly buy an antenna or string up a long wire and make sure that it's going to handle the power, because if you don't, you're going to have problems. What device increases the low ARP of a handheld transceiver? An ARP amplifier, like I told you before, about the size of 2 cigarette packs. It plugs into 12 volts, 4 amps, 4 watts input, 40 watts output. What can you do if your handheld or mobile is over deviating? Talk farther away from the microphone. You don't want to yell right, turn to the side of it. Don't yell right into it. It's going over and splatter. You don't want to do that. What name was given to an amateur radio station that it's could use to connect other amateurs through the internet? A gateway. There's some of those gateways out. You can type right over your computer and talk to other stations. Which of the following is a digital communications mode? Packet, IEE 8201, JT65. I'm not familiar with those yet. JT65 is a fairly new mode. What does APRS mean? Automatic Packet Reporting System. Some use packets. I'm not sure how all that works. I haven't gotten into that yet. Which of the following devices to use provide data to a transmitter when sending an automatic position reports from a mobile amateur radio station? That is question TA Delta Oscar. A global positioning receiver, so somebody knows where you're at. Which of the following is an application of APRS Automatic Packet Reporting System? Providing real-time tactical digital communications in conjunction with a map showing locations of stations, like you're using a GPS in the car and it'll show you where you're at. What is the PSK? Phase shift keying. PSK, phase shift keying. What of the following best describes digital mobile radio? A technique for multiplexing 2 digital signals on a single 12.4 kilohertz repeater channel. That's not used very commonly anymore. Which of the following may be included in packet transmission? That is question Delta 8, Delta Oscar number 8. That's going to be in your test. A checksum permits error detection. A header that contains the call sign of the station for the information is being set. Automatic repeater in the case of what code is using for sending CW on the amateur bands. International Morse code. That's used all through the world. Anybody that can use Morse code, it's a common language all through the world. No matter what country you're from, what language you speak, everybody can understand the Morse code. It's just a keying effect. Which of the following can be used to transmit a CW in the sideband? Straight key, which is like this. Electronic key, which you can do. You can even use a keyboard nowadays if you don't want to use a paddle, or computer keyboard, or electronic key like a bug, back and forth. An ARQ transmission. Digital scheme whereby receiving the station detects errors and sends a request to the sending station to retransmit the information. Module 5, okay. Take a short break. Once again, everybody, appreciate you coming to the class. I hope this is, is there any questions about this so far? Anything you don't understand? Not very much. Radio, I don't think it's very common use mode. There are some receivers that'll decode it, but it's very, very fast.
Can you give me what I need? Just give me what I want, baby. Can you give me what I need? Just give me what I want. Just give me what I want. Give me what I'm looking for. Can you give me what I need? Just give me what I want, baby. Can you give me what I need? Just give me what I want. Just give me what I want. Give me what I'm looking for.
Okay, this last section, we're going to be talking about power supplies and what all powers the battery, powers the radios. Most of the modern equipment runs from 12 volts, but you know it's going to be 12 volts or 13.8. It's all interchangeable basically, so you don't have to worry about that. But anything more is about 12 volts. If you go out and buy an HF radio, more than likely you'll have to buy a 12 volt power supply to power it. Some of the HF radios do have built-in power supplies. These are physically heavy radios. They've got a big transformer in them. But most of the radios you'll buy, you will have to buy an external power supply. The actual preferred voltage is 13.8, and the house AC current or power is 120 volts AC. So these power supplies. All they do, they bring that 120 volts AC down to 12 volts DC, like that. You can. If you use a lab type 12 volt power supply. Now most of the power supplies you'll see are these big power supplies, physically big power supplies. They're very heavy, they got a big transformer in them. A lot of them have a front panel control where you can actually adjust the output voltage. They'll have a meter on it with a little red line at 13.8 where you can actually adjust that voltage right up to the 13.8 limit. Those are called linear power supplies, the one that's got the great big transformers in them. They're the big box linear power supplies. They use these big iron transformers, and that's what makes them so darn heavy, is the power transformers inside them. Very heavy physically. They don't emit any RF, and they're generally immune to RF. You want them immune to RF because when you're transmitting out an RF signal, if it would happen to get back in your power supply, then it'll start affecting your signal and everything. The switching power supplies do have RF on them and they can interfere. A switching power supply, though, is a whole lot smaller. The one I've got at home on my HF rig, my switching power supply, is about twice as thick as these manuals, is all it is. It's a very small thing, about this thick, so big around. I like it because of the nice small size. Now, if you're going to be doing a lot of transmitting, you'll want the bigger power supply because they can handle the amperage out a lot better than the switching ones can. But they are lightweight and small. And I'm a casual-like operator. I'll get on, once in a while. I don't really get on the air a whole lot continuously, so switching does fine for me. You should check out the product reviews because we'll be finding out that on these continuous duty power supplies is how much current that can be supplied continuously. The big ones, the big linear amplifiers, they can supply 18 amps constantly. My HF radio at home, if I go up full 100 watts, it pulls about 18 amps. My little switching power supply would start getting hot doing it. But since I'm on sideband and the voice peaks go up and down, it's not a really constant, continuous voltage supply. The intermittent is when you do it on voice peaks. The intermittent supply, the voltage, the current going to your radio will vary. If you're on FM, you'll be full heavy current. If you're on sideband, that current will vary with your voice. The regulation is how well the power supply maintains constant voltage output. Very important. If you came from the CB world coming into the ham world, you see the little bitty power supplies that you put on a CB radio. Some of them weren't even regulated very well. They were just a brute power supply. Those things will not work. You're going to have to, when you go out and get your power supply, if you're going to get the big linear one, which is I recommend, because I don't know what kind of work you're going to be doing, if it's going to be a lot of continuous power or not, but you'll get a big power supply. You want one that'll put out minimum 20 amps. It's better to get a 30 amp one. Even though you won't be pulling 30 amps, you're still not working that power supply as hard. The car batteries, they hold a lot of energy, and shorting shorting a battery could cause a fire. Mainly you got to watch the car batteries, because like I said, they've got so much current. If you short wires out, if you do something silly like pull out the 5 amp fuse and put in a 20 amp fuse, you can start fires. You should fuse both the positive and negative lead. Remember that when we talked in an actual battery, the car battery, the current actually comes out of the negative and goes into the chassis. Well, you want to fuse it right where it's coming out. If you fuse it just on the positive side, something well in between can go wrong, and you're still going to be pumping out the current. So you do want to fuse both the power, positive and the negative leads. That negative lead, you should go right straight to the negative terminal on your battery. On my truck out here, I don't. My truck's in the engine compartment has got a big fuse box conglomeration thing in there where it goes straight to the battery. That's where I hooked my 12 volts in that fuse block, because it had a fuse setting there for 20 amps, and that's what I put it on. Definitely use grommets. Those are the little rubber things, looks like donuts when you're going through metal, to protect the wire so it doesn't scrape and short out. And the big thing here is don't assume all the metal in the car is grounded. A lot of the dashes do have a metal strip under the dash, but that's just strictly for physical strength, to keep the plastic from vibrating. So it is not connected to the chassis ground, and that's what you want to get to. So you do have to watch where you do put the grounds at. Batteries. It creates current through the chemical reaction. There's a bunch of different chemical reactions we'll go through in just a second. A lot of the times, if you open up like a little 9-volt battery, just for curiosity, tear the metal jacket off, you'll see it's a bunch of little separate cells all hooked together in it. The chemicals determines the voltage per cell. There's different types of batteries too. There's the disposable type. They're the regular carbon zinc batteries. You got your flashlight, they're dead, you throw them away. There are then the rechargeable batteries. These are the nickel cadmiums, somewhere up here. We're going to be running into that. The energy capabilities is rated in amp hours. Amps times the time you're going to be pulling the amps out of the battery. For instance, a 60 amp hour battery will produce 60 amps for 1 hour, and then it starts petering off, right? So that's what they're talking about, amp hours. If you're working field day, you might bring a car battery out to run your radio field day. You'll know that the radio, if you're talking pretty good, it can pull maybe 15 amps. So you're dealing a 60 amp one, that's about 4 hours you'll have of operating on a battery. The battery charging, some batteries can be charged, some can't. And you should use a proper charger for the batteries. Some batteries, it's best if you recharge them really slow. And then others, like a car battery, you can pump a lot into them all at once. They say batteries will lose its capacity each cycle. Each batteries, every time you charge a battery, it won't charge up. It'll charge up to the right voltage, but it won't have the current available for use. And of course, if you got batteries, maintain fully charged. And overcharging a battery can cause heating and could damage the batteries. Batteries can explode. The lead acid battery. heavy gauge and kept as short as possible. It's pulling a lot of current. A small wire will develop a lot of heat and can melt the insulation on the wire, and then you got a fire going for you. So, and it'll also really lower, small wire will make the voltage drop way down. Which computer sound card, check on something, no, still okay. Which computer sound card port is connected, go back here. Did I skip something? No, I guess not. Which computer sound card port is connected to a transceiver's headphone or speakers for digital modes? It's the microphone or line input. So instead of using your microphone now, your sound card is going to be hooked in where the mic is hooked in at. That's what they're getting to here. Which of the following conductors provide the lowest impedance to RF signals? It's a flat strap. Basically what they're doing is the ground wire, it's best to use a flat strap. RF won't be as prevalent to be picked up by a flat strap as it is just a regular straight wire. Which of the following could you use to cure distorted audio by RF current in the shield of a microphone cable? It's a ferrite choke. A ferrite choke looks like a little bitty donut made out of graphite. And you just run the wire through it a couple times, and it'll take any of the RF current off the shield of the microphone. The reason you don't want RF shield on the microphone, two reasons. First of all, it'll distort your audio, and second of all, it will bite you if you up there. A lot of people run into that. They didn't realize what was happening, but RF was getting on the microphone, and they were getting a little RF burn. And the bad thing about an RF burn, I hope you guys never get one, an RF burn burns deep. It's not like just a surface burn like you put your cigarette on your skin. It burns deep, and it takes several weeks for it to really heal properly. What is the source of a high-pitched whine that varies with the engine speed? It's the alternator. You can buy, for the alternator, you can buy a little thing, it looks like a little bitty transformer, you can just put it right in the hotline, and that will usually block the whine coming from the alternator. Why should the negative return connection of the mobile transceiver be connected? And there you want to connect that ground to right to the battery or to the engine block. You want to make darn sure you've got a really good connection. Okay, this is one that's important to know, but you all know it, right? The volts for a mobile transceiver usually requires 12 volts. This includes VHF, UHF, HF. It's all basically 12 volts. Which of the following battery types are rechargeable? It's the metal hydride, the lithium, and the lead acid gel cell. Which of the following battery types are not rechargeable? And that is the carbon zinc. Your regular flashlight batteries are AA, AAAs, Ds, whatever, Cs. What type of circuit controls the amount of voltage from the power supply? And that is the regulator circuit. In the power supply, you got 12 volts, 110 volts coming into it. It goes into the transformer. Out of the transformer, it drops it down to, maybe 16 volts. And then you got a couple diodes that start rectifying it, so it keeps it going just in one direction. You get a pulsating DC, and the rectifier takes that pulsating DC and it smooths it out and puts it at whatever you adjust it to, 13.8 volts, for instance. But that's what the regulator does. Another good one to know. What is the following common reason for using a shielded wire? Is to prevent the coupling of unwanted signals to or from the wire. This is especially true inside the radio, because inside the radio you're going to have various radio frequencies being zapped around by all the oscillators, and if you just got a straight wire out there, those magnetic fields will be picked up by this wire, and then it's going to start screwing with the frequency stabilization. It'll mess with the audio quality and everything else. So you definitely use the shielded wire to prevent coupling of unwanted signals to or from a wire. Everybody got that? Good. Next week, we'll be doing number 6 and the questions associated to it. Make sure that you go over all these questions. There's a lot of questions in the back of the book, but you will be seeing 35 of them. And they will be coming up. Read the question, read the correct answer. And if there's one that's giving you a little bit of trouble to memorize, come and see us and we'll talk about it. Maybe get a way where you can remember it better, or it just might help you to know the all bad choices. Usually on these federal tests, if there's a question that says all of the above, that's usually a good choice if you're not sure. You always pick the all of the above. And like most of them too, that usually you can knock off one or two answers immediately. You'll know they're wrong. So then you only got to guess which of the remaining two is correct. But the big thing is, read number 6. We'll be going over that next week. Number 6 is, what is it all about? It is about, contact. This is about actual ham radioing now. We're talking about contact basics. We'll be talking about band plans, how to make contacts. And the big one is how to use repeaters. Repeaters are fairly easy to use once you know just a few things about it. We'll be talking about emergency communications, nets. We have a net every Wednesday night at 7 o'clock on the 2-meter repeater. So once you get your license, every Wednesday night at 7 o'clock, you can get on there. And basically, we just check in and we tell everybody what we've been doing. Just a general chit-chat. The club meets the 3rd Tuesday of every month. I don't know what it is in March, but we got a club meeting coming up, and we'll be at the Funkhauser Church in Funkhauser. You guys are all invited to the club meeting. I hope you all show up. Once you get your license, you are given a 1-year free membership to the National Trail Amateur Radio Club. So you can get to know the guys, because once you get your license, it will take a while before everyone gets used to your call signs. And I said it earlier, I think before the class, you guys will be getting a call sign KD9, probably P, and then 2 letters behind it. So it'll be KD9P XX, something like that. So that's where we're going with your license. And then once you get your license, if you have a relative that's passed away that was a ham radio operator, you can apply for his or her call sign. Or if you want to, you can look it up on the data net, and you might want to get a call sign that's like KD9 and then your 3 initials. If it's available, you can have it. I mean, there's no extra charge for it. In fact, at the National Trail Amateur Radio Club, we take care of the paperwork for you. So you can get it. So that's really good. Pardon me?
What time was that?
7 o'clock. It's at 7 o'clock at Funkhauser. It's the 3rd Tuesday of every month. And then that's during the winter time. And now it looks like starting, in April, we're going to have meetings here, I think, right? Okay, but we'll be doing that at the next meeting to do it. We were having the American Legion down in Edgewood was really nice to us. They give us a room down there to use, and we have been going down there for meetings and stuff, but it's a long drive. Edgewood is halfway to Mississippi, I think. It's a long way down there to drive. And like our secretary lives over in Montrose, so she had to drive from Montrose all the way down to Edgewood. And so that's why we want to get just a little bit closer in town. Have fun. So anyway, go over those questions and answers this week. Read chapter 6, and next Thursday night, we're going to do it again.